All right, so here we are. We're back with a series of questions, and these are not from an exam paper. These are just revision questions that a subscriber of mine sent to me, and I will be solving these. So these are from topic one, as you may have noticed, and topic one, which deals with stoichiometry, is often probably many students actually find this topic a lot difficult, including myself at one point of time. Even I found it a lot difficult, but it is actually a very easy topic if you really understand a few concepts, and then you can solve any question in the exam and score good marks. So let's look at the first part, which involves the reaction of B2H6 with oxygen to produce HBO2 plus water. Now, when you're given such a question in the exam or while you're practicing, the first thing you need to ensure that the equation given to you is balanced. Now, sometimes it'll be balanced and the other times it may not be balanced. So please make sure that it is balanced. Otherwise, all the preceding questions, if your ratios are wrong, your answers will be wrong. So that's why it is very crucial you ensure that the equation is balanced. And in this case, the equation is not balanced. So that's what we need to do first. So it's B2H6. Now I've done all the calculations and I'm sure you would know how to balance an equation by now. But if you do not know how to do it, I would strongly suggest you to go revise, or you can drop a comment below this video asking me to cover this topic or about balancing equations, and I will do it happily, because it's a very important concept that you will use not only in this, but even in later topics. So this is the balanced equation. And you see that the stoichiometric ratios have changed, and it is not the same as the equation given to us in the question. And this is where the crucial part comes. It is very important for us to know what the stoichiometric equations are. If there is no number over here, just a pointer, if there's no number, that means that there is a 1. Now, what mass of oxygen will be needed to burn 36.1 grams of B2H6? Now, first thing we need to do is convert this mass of grams of B2H6 into moles. So let's find out how many moles of B2H6 do we need to burn. So in order to find out moles, I'm sure you know this equation. Number of moles is equal to mass in grams of the substance over its molar mass. So the mass is given to us, it's 36.1 grams, and the molar mass of B2H6 is 27.66, and you can calculate this using your periodic table very easily. And this gives us a mole, the number of moles of 1.30. All right. Now, in order to calculate the mass of O2, we need to find how many moles of O2 there are first. And well, we know the number of moles of B2H6, which is 1.30, and we see that the molar ratio of B2H6 to oxygen is 1 to 2. So for every 1 mole of B2H6, you will require 2 moles of oxygen, or O2. So that basically means the number of moles of oxygen is the number of moles of B2H6 multiplied by 2. So the number of moles of oxygen in this case is 1.30 times 2, which is 2.6. If I'm not wrong. Yeah, okay, that's right. So these are the number of moles of oxygen required to entirely burn B2H6. But in the question, they've asked us the mass of oxygen required. And now that you know this equation over here, it will be very easy to find out the mass, because, well, you know what the moles is and you know what the molar mass of O2 is. So you just need to rearrange this equation in order to find out what mass is. So I'm just going to do that right here. I'm going to erase this. So it's 2.6 is equal to 32, because the relative atomic mass of oxygen is 16. So O2 would be 32. Sorry, that's a 3, 32. And we'll just call the mass in grams of oxygen as X. Now solve for X. X is equal to 32 times 1.6, which is equal to 83.6 0.2 grams. That is your answer. So that is the mass of oxygen required to burn 36.1 grams of B2H6. Now, let me just erase this so we can solve part B. If you would like to look at my working, just pause the video and look at it, because it'll be very hard for me to solve the questions because I have very limited space over here. So, okay, part B. How many moles of water are produced from 19.2 grams of B2H6? So let's first calculate the number of B2H6, or the moles of B2H6 that is being burned. So that would be 19.2, which is the mass in grams, divided by the molar mass, which is 27.66. And this gives us 0.694 moles. And a quick reminder, this is a calculator question, so you can use your calculator, because it'll be very hard and challenging to solve or to do such division without a calculator. So yeah, that's the number of moles of B2H6. And now if you look at our equation over here, if you look at the ratio, B2H6 and H2O over here, water, are in a ratio of 1 to 2. That means that for every 1 mole of B2H6, you will produce 2 moles of H2O, or water. And that essentially means, in order to find out the number of moles of water produced, just multiply the number of moles of B2H6 by 2. So that would be 0.694 times 2, which is equal to 1.388 moles. And that is your answer. That's how many moles of water will be produced from burning 19.2 grams of B2H6. Now let's look at the next question. Let me just erase all of this. I hope that you have understood it so far. All right, so calculate the mass in kgs of water produced from the combustion of 1.0 gallon, or 3.8 liters of gasoline, C8H18. And they have told us that the density of gasoline is 0.79 grams per milliliter. Now, the first thing that you need to understand is that density, the formula for density, is equal to mass over volume. And in this case, they have told us that the density is in grams per milliliter. That means the mass, the unit that they have measured the density is in, or the unit of these two variables over here, the mass is measured in grams and the volume is measured in milliliters. So the first thing we need to do is find out the mass of gasoline. Now, why do we need to find out the mass of gasoline? Because we will use this mass to find out the moles of water produced. Now, you may be a bit confused now about what's going on and how I've derived all of this. And this is the point that I'm going to make, is that the first thing you do when you see such a question is to write down the reaction equation. So in this question over here that we solved earlier, they had given us the reaction equation. But in harder questions like this one, they will not give you the reaction equation. So you have to find that out, or you have to jot that down by yourself, because without the reaction equation, solving this question correctly will be very hard. So let's look at the reaction equation. So they have said that it's combustion. And combustion basically means you react, the substance reacts with oxygen, or it burns and produces carbon dioxide and water. So C8H18 will react with oxygen to produce carbon dioxide plus water. Now, this holds true for nearly every substance which is carbon based. So coal or alcohol, if you follow through with the combustion, which you will learn later in topic 10, but this is the standard. Every time you react something with oxygen, or this is what you need to know for the IB at least. Every time you burn something, you will produce CO2 and H2O always. And in this over here, in this equation over here, it's not the same because you don't have any carbon. This is B2H6. There's no carbon here, so you can't produce carbon dioxide. Anyways, moving on. Now this equation is not balanced. So let's balance this. I've already done the balancing, and you can do that in your free time if you would like to. So that's 25 oxygen. This is 16 CO2, and this is 18 H2O. Now let's just make sure everything is correct. So let's see how many carbons there are. There are 16 carbons here, and there is 36 hydrogens, and there is 50 oxygens. Now let's look at this side. Over here for carbon, there are 16, which is good, the same on both sides. For the hydrogens, there are 36, which is also good. And for the oxygen, there are, over here, there we have 36 plus 18. Hold up, no, that's not right. So 32 plus 18, which is equal to 50 oxygen. So yeah, we have balanced this correctly. Now, let me get to the point that I was making before. So now we need to find out how many moles of C8H8 or gasoline is being burned in order to find out the number of moles of H2O or water produced. And if we find out the moles of water produced, we can easily find out its mass in grams or kilograms by using the N is equal to M over capital M equation that I showed you earlier, this one. Yeah, but anyways, let's first find out the mass of gasoline that is being burnt. So they have given us the density of gasoline. So that density is equal to, so that is 0.79 is equal to mass, which we don't know, X over the volume. They've told us the volume, it's 3.8 liters. But since the density to us is given to us in grams per milliliter, we have to convert the liters into milliliters. And 3.8 liters is equal to 3,800 milliliters. So that means the mass of gasoline burnt is equal to 3,002 grams of gasoline. Now that we found out the mass of gasoline, we can easily find out the moles of gasoline that has been burnt, and that is we already know the equation. This is mass in grams over the molar mass of C8H18, which is 114.23, and this gives us 26.28 moles of gasoline. And you can see from the equation that gasoline and H2O are in the 2 to 18 ratio, or 1 to 9 if you reduce it. So that means for every 1 mole of gasoline burned, you will produce 9 moles of water. So in order to find out in this context, you just have to multiply the number of moles of gasoline burnt by 9. So that is 26.28 times 9, which is equal to 236.52 moles. Now, once you found out the moles of water produced, we can easily find out its mass in kilograms by using the exact same equation we use now, but we just have to shuffle around the variables. So now in this case, we know what the moles are. We know that it's 236.52. And we know what the molar mass of water is. It's approximately 18. and we just need to find out x, which is the mass of water. So we just multiply this by that, and x is equal to 4,257.41 grams of water has been produced. But they've asked us the mass in kilograms, so just divide this by 1,000, and your answer is 4.25 kilograms approximately. So that is the answer for the second question. Now, let's move on to the last section. Now, I do agree that this question was a bit tricky, and I hope that I've done a good job at explaining it. If you do have any questions, or if you would like me to explain something in more detail, please leave your questions in the comments and I'll do my best to answer them as soon as possible. All right, next question. 1 mole of aspartame reacts with 2 moles of water to produce 1 mole of aspartic acid and 1 mole of methanol and 1 mole of phenylalanine. What is the molecular formula of phenylalanine? So that's a mouthful. So again, first thing, let's write down the reaction equation. So that would be C14H18, quite a big compound here, N2O5 reacts with 2 moles of water, that's why the 2 is over here, to produce. Now, just one thing before we proceed, I want to clear something. This over here, this 2 moles, this does not mean that there are 2 moles of water, meaning this does not mean that exactly 2 moles of water are being reacted. This is a molar ratio, so do not confuse yourself. These are a ratio of the elements together. So this just tells us that how much one element is used in the reaction compared to another element. So in this case, you use double the amount of water when compared to aspartame. All right, so C4, so aspartame reacts with 2 moles of water to produce 1 mole of aspartic acid, which is C4H7NO4 plus 1 mole of methanol, which is CH3OH, and 1 mole of phenylalanine. Now, they have not told us what the molecular formula of phenylalanine is, and that's something that we have to figure out. Now, this is very easy to do. You just have to balance the equation. Basically, you have to use the same logic, because as you can see that this equation is not balanced because you have this empty, you have this question mark over here because you don't know what the element is, you don't know what the molecular formula is. And the molecular formula of phenylalanine is everything is basically made up of the elements that have not been used yet. So for example, on this side, you have 14 carbons, but on the right-hand side, you have only used 5 carbons. So the remaining 14 minus 5 is 9. So that means that the first component of the molecular formula of phenylalanine, which is carbon, is 9. So it's C9. And then you do the same for the others. Let's take a look at hydrogen. They have on the left hand side you have 18 hydrogens, but then on the right hand side you have only used 11 hydrogens. So that would mean that you have, sorry, my apologies, I got a bit confused. You have not used 18 hydrogens, you have actually used 22 hydrogens, because let's not forget the hydrogens come from the aspartame, and the hydrogens are also there in the water. So there are 22 hydrogens because there's 18 plus 4. So that's 22. So you've used 22, there are 22 hydrogens on the left-hand side, but we have only used 11 hydrogens so far on the right-hand side. So that means the next component of the molecular formula of phenylalanine is hydrogen, which would be 11, because 11 plus 11 is 22. So that would make the equation balanced. Then let's take a look at nitrogen. There are two nitrogens on the left-hand side. However, there is only one nitrogen on the right-hand side. That means there is one N. And now the final component is the oxygen. So there are 7 oxygens on the left-hand side. However, we have only used 5 on the right-hand side. So that means there will be O2. So the molecular formula of phenylalanine is actually C9H11NO2. So this is the molecular formula. I hope you've understood what I've done. I'm sorry if what I'm saying is a bit confusing, but please rewatch the video if you have not understood, or leave a comment down below and I will answer it as soon as I can. Now let's look at the next part. What mass of phenylalanine is produced from 378 grams of aspartame? All right. So again, we need the balanced equation for this. So I don't know why I erased that. I'm just going to write it now again in a more neat fashion. Into O5 plus 2H2O gives us C4H7N4 plus CH3OH plus our phenylalanine, for which we calculated the molecular compound earlier, 11NO2. Yeah. So what is the mass of phenylalanine produced from 378 grams of aspartame? So first, let's calculate the moles of aspartame. So that's 378 divided by the molar mass. And I've calculated the molar mass. It's 294.3. And that gives us 1.284 moles of aspartame. And as you can see, the mass of or the aspartame and the phenylalanine are in the 1-to-1 ratio. So that means that 1.284 moles of aspartame is producing 1.284 moles of phenylalanine. Now, all we have to do to calculate the mass is to use the N is equal to M over M equation, just like we did over here. But we just have to rearrange the variables. So it's 1.284 is equal to the mass in grams, which we need to find out, which is X, and the molar mass of phenylalanine, which is 165.19. And this gives us X, or the mass of phenylalanine used or produced actually, is 212.17 grams. That's the answer. So that is it for this video. This video has been quite long. I am sorry if I may be a bit unclear to understand at some points. I will try to work on that. And hopefully I have helped you get a better understanding of this topic. And if there are any other questions or topics that you would like me to cover, please let me know on my social media down in the comments, or send it to me by email, and I'll be more than happy to help you out. Thank you, and I will see you in the next video.